एटम्स एंड मॉलिक्यूल, परमाणु एवं अणु। Ancient Indians and Greek philosophers have always wondered about the idea of divisibility of matter was considered long back in India around 500 BC. An Indian philosopher Maharishi Kannad postulated that if we go on dividing matter, we shall get smaller and smaller particles. Ultimately, a stage with a stage will come when we shall come across the smallest particles beyond which further division will not be possible. He named this particle Parmanu. Another Indian philosopher, Pa- Pakudha Katyama, elaborated this doctrine and said that these particles normally exist in a combined form which gives us various forms of matter. Around the same era, ancient Greek philosopher Democritus and Leucippus suggested that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. Democritus called these invisible particles atom, meaning invisible. All this was based on philosophical consideration and not much experimental work to validate democratic dividing matter. A stage will come when particles obtained cannot be divided further. Democritus called these invisible particles atoms, meaning invisible. All this was based on philosophical consideration and not much experimental work to validate this. India could be done till the 18th century. By the end of 18th century, scientists recognized the difference between elements and compounds and naturally became interested in finding out how and why elements combine and what happens when they combine. Antoine L. Lavoisier laid the foundation of chemical science by establishing two important laws of chemical combination. प्राचीन भारतीय एवं ग्रीक दार्शनिक द्रव्य के अज्ञात एवं अदृश्य रूपों से सदैव चकित होते रहे। पदार्थ की विभाज्यता के मत के बारे में भारत में बहुत पहले लगभग 500 ईसा पूर्व विचार व्यक्त किया गया था। भारतीय दार्शनिक महर्षि कणाद ने प्रतिपादित किया था कि यदि हम द्रव्य को विभाजित करते जाएं तो हम छोटे छोटे कण प्राप्त होते जाएंगे तथा अंत में एक सीमा आएगी जब प्राप्त कण को पुनः विभाजित नहीं किया जा सकेगा, अर्थात वह सूक्ष्मतम कण अविभाज्य रहेगा। इस अविभाज्य सूक्ष्मतम कण को उन्होंने परमाणु कहा। एक अन्य भारतीय दार्शनिक फकुदा कात्यायन ने इस मत को विस्तृत रूप से समझा तथा कहा कि ये कण सामान्यतः संयुक्त रूप में पाए जाते हैं जो हमें द्रव्यों के भिन्न भिन्न रूपों को प्रदान करते हैं। लगभग इसी समय ग्रीक दार्शनिक डेमोक्रिटस एवं ल्यूसिपस ने सुझाव दिया था कि यदि हम द्रव्य को विभाजित करते जाएं तो एक ऐसी स्थिति आएगी जब हम कण को पुनः विभाजित नहीं किया जा सकेगा। उन्होंने इन अविभाज्य कणों को परमाणु अर्थात अविभाज्य कहा था। यह सभी सुझाव दार्शनिक पर आधारित थे। इन विचारों की वैधता सिद्ध करने के लिए 18वीं शताब्दी तक कोई अधिक प्रयोगात्मक कार्य नहीं हुआ था। 18वीं शताब्दी के अंत तक वैज्ञानिकों ने तत्व एवं यौगिक के बीच भेद को समझा तथा स्वाभाविक रूप से यह पता करने के इच्छुक हुए कि तत्व कैसे तथा क्यों सहयोग करते हैं। जब तत्व परस्पर सहयोग करते हैं तब क्या होता है। वैज्ञानिक अथवा एल लवाइजिए ने रासायनिक संयोजन के दो महत्वपूर्ण नियमों को स्थापित किया जिसने रसायन विज्ञान को महत्वपूर्ण आदान प्रदान किया। Law of chemical combination. The following two laws of chemical combination were established after much experimentation by Lavoisier and Joseph L. Proust. Law of conservation of mass. Is there a change in mass when a chemical reaction take places? रासायनिक संयोजन के नियम। लवाइजिए एवं जॉर्ज एल प्रोस्ट ने बहुत अधिक प्रायोगिक कार्यों के पश्चात रासायनिक संयोजन के निम्नलिखित दो नियम प्रतिपादित किए। द्रव्यमान संरक्षण का नियम। जब रासायनिक अभिक्रिया संपन्न होता है तब क्या द्रव्यमान में कोई परिवर्तन होता है। अब लॉ ऑफ कांस्टेंट प्रोपोर्शन। Lavoisier along with other scientists noted that many compounds were composed of two or more elements and each such compound had the same element in the same proportions irrespective of where the compound came from or who prepared it. In a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is if 1:8. Whatever the source of water, thus if 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen always obtained. Similarly, In ammonia, nitrogen and hydrogen are always present in the ratio 14 ratio 3 by mass. Whatever the method or the source from which is obtained, this lead to the law of constant proportion, which is also known as the law of definite proportion. This law was stated by Prost H. In a chemical substance, the elements are always present in definite proportion by mass. The next problem faced by scientists was to give appro- appro- appropriate explanations of this laws. British chemist John Dalton provided the basic theory about the nature of matter. Dalton picked up the idea of divisibility of matter, which was till then just a philosophy. He took the name atoms as given by the Greeks and said that the smallest particle of matter are atoms. His theory was based on the laws of chemical combination. Dalton's atomic theory provided an explanation for the law of conservation of mass and the law of definite proportion. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of smaller particles and called atom. The postulates of this theory may be stated as follow. All matter is made of very tiny particles called atoms, which participate in chemical reaction. Atoms are indivisible particles which are cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties.